TEKS 10E, factoring when A is greater than 1 notes. Okay, so last week we learned how to factor when A is equal to 1. Now we're going to learn how to factor when A is greater than 1. It's some of the same steps, so it should be nothing entirely new, just a little different. Okay, so on the notes part, it says quadratic equations. Remember, the quadratic equation looks like ax squared plus bx plus c, where a, b, and c, so a, b, and c are coefficients. These are all numbers. They're numbers. Coefficients. Some of you are getting confused on the last quiz, and instead of putting the coefficient for a, b, and c, you were putting x squared, you were putting x. So I just want to clarify that a, b, and c are coefficients. Okay, so here are the steps. So the steps for factor by grouping. So it's very similar to what we did before. The only difference is that we're going to try to take an additional GCF out in the beginning. So we're going to take out a GCF in the beginning. We're going to multiply a times c and find the factors that add up to b. We're going to group them, and we're going to factor out the GCF at the end. So let's look at example 1. So example 1 says 16b squared plus 60b minus 100. So our first step is to see what the GCF is of this equation. So what number can we divide everything by? So let's first label our A, B, and C. So A is 16, B is 60, and C is negative 100, those coefficient numbers. All of these numbers are divisible by 4. That's the biggest number that we can divide into each of them, 4. So I'm going to divide each one by 4. This 4 is our GCF, so GCF is equal to 4. So if I divide them all by 4, 16 divided by 4 is 4, 60 divided by 4 is 15, and negative 100 divided by 4 is negative 25. So that's our first step. Our first step was to factor out any GCF, any number that we could factor out from each of them, and this is going to help us make our problem easier. Okay, so now I'm going to rewrite my equation. So my A, which was 4, becomes 4b squared plus 15b minus 25. So now we're looking at this equation, and we're no longer paying attention to this one because we already factored out the GCF of that one. Okay, so now we're going to create our table just like we did on the last one. So here's our table. And remember, in the first column goes A times C, and the second column goes B. So A times C in this case is going to be 4 times negative 25. So 4 times negative 25, which is negative 100. And B is 15. So we need to find two numbers that multiply to negative 100 but add to 15. And those two numbers are going to be 20 times negative 5. Because 20 times negative 5 is negative 100, but 20 plus negative 5 gives us 15. So this is our pair we're going to work with. Remember, as soon as we finish a pair, we don't have to worry about finding other ones. Okay. So now I'm going to rewrite it just like we did before. So I have 4b squared. And then now we can't just put the numbers wherever we want to. So before, we didn't matter what term came first. Now it matters because we have to be able to take out a GCF from both those numbers. So for example, if I did minus 5b plus 20b minus 25, I could not factor out a GCF from 4 and negative 5. So because of that, I'm going to have to switch these two numbers. So I'm going to have to write plus 20b minus 5b and then the minus 25. So now if I factor it or group it, I can now take out a GCF from both of those numbers. So the GCF, the biggest number I can take out of 4 and 20 is 4. And the most variables I can take out of both is just the b. So 4 divided by 4 is 1, so I don't have to write anything. B squared divided by b is b. 20 divided by 4 is 5. And b divided by b goes away, so I'm left with that in the middle, b plus 5. So right here, what I took out of these two terms was this first one, this 4b right here. Okay. And then what I can take out of this one is going to be that -5, because -5 goes into both those numbers. So I'm left with b plus 5. Same as before, my parentheses have to match. These have to match right here. And again, I took out that first term here. So I'm taking out the first one from each one. So that means my answer is b plus 5 and 4b minus 5. Same as before. Okay. Just like last time, this seems like a lot of steps, but as we're going through it, it's going to get easier and easier. Okay, let's look at number 2. Number 2 says 6n squared plus 5n minus 6. So I'm first going to label my a, b, and c. So a is equal to 6, b is equal to 5, and c is equal to -6. Can I take out a GCF from this a, b, and c? So there doesn't look like there's a number that can come out of here besides 1. So I'm just going to go ahead and divide each one by 1 because that's going to be my GCF. GCF is equal to 1. And if I divide anything by 1, it doesn't change. So I still get 6, 5, and -6. So that means I'm still using this same equation. I don't have to rewrite any equations. Okay. So now I'm going to create my table. The first column goes a times c. The second column goes b. A times c is 6 times -6, which is -36. And b is 5. So we need to find two numbers that multiply to -36 but add to 5. And those two numbers are going to be 9 times -4. Because 9 times -4 is -36, but 9 plus -4 is 5. So that means these are our numbers we're going to work with. Okay. So I'm going to go ahead and rewrite it. So I have 6n squared plus 9n minus 4n minus 6. Notice that since there's a 6 on both sides of our equation, it didn't really matter where I put the 9 and where I put the -4, because either way it's going to get attached to a 6. So in this case, it didn't really matter. So I'm going to go ahead and group them. Okay, so what can I take out of 6 and 9? The biggest number I can take out of 6 and 9 is 3. So 3. And then the most variables I can take out is n. So if I take out a 3n from 6n squared, I'm left with 2n. And if I take out a 3n from 9n, I'm left with just the 3. So 2n plus 3. Okay. From here, from -4 and -6, I can take out a -2. So I'm left with 2n plus 3, because remember, these need to match. So that means my answer is 2n plus 3 from the parentheses and 3n minus 2 from the outside, just like before. Okay. One thing I forgot to mention, guys, is let's go back at looking number 1. Do you remember when we pulled out that GCF of 4 right here? That GCF of 4 actually needs to go right in front of our problem. My bad, I forgot to put that there. So that means in this one, in number 2, right here, our GCF was 1, so we're going to put a 1 right in front. The reason for this is that if you forget to put that original GCF in these problems, then technically you are factoring the wrong equation. Whatever GCF we take out in the beginning has to be put back inside our problem. Okay. Okay, so let's look at number 3. On number 3, I want you guys to change this problem, and I want us to work on a different one. So I didn't like this problem so much, so I'm going to change this to 9k squared plus 66k plus 21. That way we can find a GCF that we can factor out of each of them. So let's label our A, B, and C. So A, B, and C. A is 9, B is 66, and C is 21. So in order to find a GCF, or a number that can divide into each of them, what number can divide into both 9, 66, and 21? Well, that number is going to be 3. So I'm going to divide each one by 3. So that means our GCF is equal to 3. So I have 9 divided by 3, which is 3, 66 divided by 3, which is 22, and 21 divided by 3, which is 7. So since I had a GCF that wasn't 1, I now have to rewrite my problem. So I have 3k squared plus 22k plus 7. So no longer am I dealing with this original equation. I'm now dealing with this one right here. Okay, so I'm going to create my table. So remember, A times C and then B. So A times C is 3 times 7, which is 21, and B is 22. So I need two numbers that multiply to 21, but add to 22. And those two numbers are going to be 21 times 1. Because 21 times 1 is 21, but 21 plus 1 is 22. So these are our answers, 21 and 1. Okay, so I'm going to go ahead and rewrite this. So I have 3k squared plus 21k plus 1k plus 7. Okay, now I'm going to put them in parentheses and start taking out the GCF from each one. So in this first one, I can take out a 3k, and I'm left with k plus 7, right? Because if I take out a 3k from each of these, 3 divided by 3, I just get k. 21 divided by 3, I get 7. K's cancel out. From this one, it doesn't look like I can take out a GCF for any of them, so I'm just going to assume I'm just taking out a 1. So if I take out a 1, nothing changes. I'm still left with k plus 7. So that means my answer is k plus 7 from the parentheses and 3k plus 1. But what did I say before? Our GCF always has to go in the front. So our GCF was 3, so I put a 3 in the front. Now this whole thing is my answer. So that's one thing you need to remember, is to always put the GCF in the front. That's something I even forget to do. Okay, that's our answer.